right, we're looking at example 6.8. So again, we're still doing work here. So a loaded grocery cart is rolling across the parking lot in a strong wind. You apply a constant force of 30 newtons I hat minus 40 newton J hat to the cart as it undergoes a displacement of -9 meters I hat and -3 meters J hat. How much work does the force you apply do on the grocery cart? All right, so we're trying to find work. Now, work we know is F dot S, and we heard in that last example that I really want the parallel component of the force times the displacement, but these aren't in like magnitude and direction format, so it's kind of hard to resolve them into components unless I think. They're already in components. And so what the idea is the I hat force is going to do work in the I hat displacement. And the J hat force is going to do work in the J hat displacement. So to find this overall work when we have component form like this is I need to take the X component of the force times the X displacement and add it to the Y component of the force times the Y displacement. Now notice, is there an I hat and a J hat here? No, because remember we're doing a scalar product. There's no direction. So work is equal to F, which was 30 in the I hat direction, times -9. And in the Y direction, I had -40 times -3. Now it doesn't matter that these were both negative in the sense that is it taking away energy. It's more important that they're in the same direction or opposite direction. Same direction we're adding energy, opposite directions we're taking away energy. So here in the X direction I was removing 270 joules, but in the Y direction I was actually adding 120 joules. The result is I overall removed 150 joules of energy from that grocery cart. So I was removing energy. And whenever we remove energy, we are trying to slow it down. Now, does that mean it was slowing down? No, because we can only make this determination if I know all of the works. So in the idea here would probably be that the wind was trying to speed it up in one direction, but I was trying to slow it down in the other direction as I moved it along. And so the wind was adding energy, I was pulling energy out, and we maintained a constant velocity is probably what happened. But the idea is whenever you see that negative, you're removing energy, you're trying to slow it down. There's the example.